Hello guys, today we got another question. We can see this is our linear differential equation with higher order because here is 2 time derivative, here is 3 time derivative, and the derivative has got coefficient x having the power equal to the order of the derivative, means the derivative is done 3 times, so the power is 3, derivative is done 2 times, so the power is 2. So this is going to match with our Cauchy homogeneous linear equation. So we should solve it according to the Cauchy way, that we should put the coefficient. What is coefficient? X is coefficient, so we're going to replace x with e to the power t. When we take log on each side, we're going to get log x is equal to t. And finally, we're going to make our given differential equation into symbolic form, where d is dy dt. So we got here our substitution like this: x square and second derivative is replaced by d into d minus 1 into y, this y, this y. Similarly, x cube and 3 time derivative is replaced by d into d minus 1, d minus 2, at last y, as there is y. Finally, our equation 1 going to be in like this form. This is our in the form of d, and look, this is our right hand side which have been changed. Look, there it was x, and we have replaced x with e to the power t. So our right hand side become in the form of t and e. So we got 10 into e to the power t plus 1 divided by e to the power t. Now we have to solve it as usual, means the process which we have studied already. First, we are going to find its auxiliary equation. Auxiliary equation means the coefficient of y. We are going to take the y common, and we are going to equate the coefficient equal to 0. So we got this form, and we are going to solve this. Then finally, we are going to get our this form. This is cubic form, and to solve the cubic equation, we can do it by assumption method. Assumption method means like as first we have to do trial solution. Trial solution means we should place some value of d so that it can satisfy the equation. Put minus 1 in the place of d so that this one is going to be 0 and another side is also 0, means minus 1 is satisfying our equation. So minus 1 is our one of the roots. So here d equal to minus 1 is one root, and to find other remaining two root, we're going to use synthesis method, where we're going to write first decreasing pattern of the d, means d cube d square d, because our equation was in the form of cube here. So we will write in the decreasing pattern, and at last constant. What is constant? 2. So, and we will copy downside their coefficient. The coefficient of d cube is 1, d square is minus 1, and d coefficient is 0, and c constant is 2. After copying, we're going to write here one of the satisfied root, which is minus 1. So we copied minus 1 here, and finally we're going to bring this one coefficient, we'll bring it down without doing anything. So this becomes 1, then we're going to multiply with this becomes minus 1, which will be written here minus 1. Again this is going to be added, it's going to down. Again this one multiply, it becomes 2. Then you will keep that 2 here. Again this is going to be added, it will come down. Again it will be multiplied, it's going to be minus 1. Multiplied, it is going to be minus 2. So this becomes 0, and you should note that this must be 0 always. It is fixed, means if it is 0, means we are true up to here. And we are going to use this value to make another equation having 1 degree less than this, means we're going to get, here it was cubic equation, then we are going to use this to make a quadratic equation, means it is value of a, b, c, like this. We made a new equation using those value, d square minus 2d plus 2, where a is this, b is this, c is this. Then we will apply our formula to get the two root, that is d square minus b plus minus root under b square minus 4 c by 2a. And solving this, we got our other two left root, that is 1 plus minus root under minus 1 divided by 1, that is 1 plus minus root under minus 1, and minus 1 is I. So it is 1 plus minus I. And previously we had got one root, and from here we got two root, out of which one root is real but two roots are imaginary. So according to this condition, we will going to write our CF, which will be this. The roots, one is real and two are imaginary. So CF equal to, this is for real, which was minus 1. So it becomes C1 e to the power minus t. And this is for our imaginary, where we replace the value of alpha and beta, we are going to get our term. We need to find our pi. So pi equal to right hand side, and this was the value of our right hand side divided by the function of d, which you have solved in auxiliary equation. And this e to the power t will move up, it will be e to the power minus t, and this is our expression. And look, we're going to separate this denominator to this both numerator. This is plus, so we're going to get two different terms like this: 10 e to the power t divided by denominator plus 10 e to the power minus t divided by the denominator. Now it is our exponential case, and the exponential are alone, so we will replace d with a. If it is in combined form, means if the exponential appear with multiplied with other trigonometry or polynomial, then we replace d with d plus a, but it is alone, so we replace d with a. So let this one be pi1, this one be pi2. We'll solve our pi1. We're going to replace d with a where a is 1, so wherever we see d, we'll keep there 1. The work of e to the power t, that exponential has been done, so it will appear just like as multiplied, and the value of d is replaced, and we finally got our pi1 up to this much. Similarly, we're going to do for our pi2. So it is also exponential, so we replace d with a, that is minus 1, because minus 1 is the coefficient of t, that is the value of a. So we placed our minus 1 value. Finally, we're going to see that denominator is going to be 0. Means it's going to fail here. We know that if our condition is going to fail, then we should multiply the numerator and do the derivative of denominator. So we multiply the numerator, means it become t. We multiply here numerator, that is this one numerator, multiplied with t e to the power minus t 10, and we did one time derivative of the denominator. So one time derivative of this, we got this. And again, after doing this, again we replace our d with minus 1 value with respect to exponential, and finally we got our pi2, that is 2t e to the power minus t. So our final pi became like this: pi equal to pi1 plus pi2, and this is our required pi. So after solving our CF and pi, we're going to write complete solution equal to CF plus pi. We replace the value of CF and pi, and finally after placing the value, we're going to return the value of t, that was log x. Wherever there is t, we will place that log x, and doing so, we're going to get our required complete solution up to here.